Take a look at the exciting new Planwin 2014 launched by SK Future Tech. Planwin has been totally refurbished. The entire operating scenario has changed. The concept of working has changed. And we get started with new project, starting with a sample, project name, basic project information, a number of levels in the project, let's say 4, and the depth of the founding layer. Going to create a project, I can define plans. Let's say I want to define a first plan, call a typical, and I say it's applicable over the second and the third levels. I'm going to select a CAD center line from which I can actually create a plan. The CAD center line is imported, and what you see on screen is the CAD center line with all the slabs automatically detected by Planwin. Here's where, as you can see, the different starts. It's got a nice new screen, totally different from the current or existing Planwin that we're all using. A lot of new features I've added. One of the features is if I need to locate columns one shot at all locations, I can just go into column and say auto column. When I do that, Planwin by default identify columns at all possible intersections in itself. Of course, I can qualify this by going and saying, okay, select and select column, and deleting some that I don't want. Let's say I don't want this, I don't want this, this, and let's say perhaps this. Once I'm through with column locations, I'll maintain these column locations because I actually want to define a shear wall here. We'll see that as I go into the vertical frame module in itself. I need to create the beams. I just go and say auto beam, click a button, define the parameters, one click, all the beams have been defined. I can go and delete a slab, and once I'm through with the loading, I'm satisfied. I just go and say finalize the plan. Once the plan is finalized, the load transfer mechanism takes place. It checks for all sufficiencies, and we're ready to go ahead. Let's say I want to create a next plan. So we created a typical plan, and I want to create, let's say, a plinth plan using the same typical floor. So I can just go to workspace and say create a new plan. Go and define it. Let's say I want to call it plinth, and I want to assign it to obviously the lowest level, and I'm using the typical floor plate for that. So I just say create plan and imports the typical as it is, and now I can edit this. So let's say I want to delete all the slabs. I just go and say select all slabs, delete them, and that's it. My plan is ready. I just say and finalize the plan. Let's say I now need to create a roof plan. I can go to workspace, I say create a new plan, and here you will see actually the various options to create a plan. So A is the ability to import a DXF, or I can use an existing plan. So as you can see, two plans are listed here, the plinth and the typical, and I can use either of these to create a new plan. I can import a plan from any Planwin file, so it could be a new PLNX file or the current PLW files in itself, or of course I can create graphically by using the graphical interface one by one in itself. So let's say I want to use this typical floor plan to create my roof. So I can go and call this a roof plan and assign it to the top floor in itself. I say create a plan. So it imports that file, and let's say I want to delete this projection here. So I just go and say select and select, and I can just select these elements and delete them to generate my new plan in itself. That's it. My new plan is generated. I finalize it. I've created my plans, and I'm now ready to start building the structure in itself. So I go to workspace and just say go to the 3D frame mode. You'll find the 3D frame is automatically generated and ready. You can see an isometric wireframe model here. I could actually visualize the plan. So this is my current plan in itself. I close this window. I come back to the window where all the elements are displayed. The first thing that I want to do here now is to create the walls. So the shear walls. So I go into this tool which says define a shear wall, and just define between two defined columns. So I just go from here to here, define the thickness. I just say OK. I can go from here to here, define the thickness, and go from here to here. As far as style is concerned, one fundamental change that Planwin 2014 brings to the table is the ability to model shear walls as a vertical element and rigid link option. So you actually have one vertical member which is basically the column as a column, and rigid links which simulate the behavior of the wall in itself. And this entire modeling philosophy is directly transferable to something like an RCDC, where you can do design detailing and continue the entire process forward. So that end-to-end integration is something that has been brought to the fore. The next thing that we do once we define the walls and the location of the columns is obviously to size the columns in itself. So I'm going to assign, I say column sizing and orientation, and here is something new that happens. If I go into size, we get multiple options here. So one is where the columns are rectangle, circular or square. So I can define all columns by their shape here in itself. Another option that's built in here is the ability to define whether you want to maintain sizes. So typically, let's say in a say 4-story structure like this, I want to maintain the sizes over the first 2 levels and the last 2 levels. So I'm just saying maintain sizes here, and if I define the parameter and say auto design, you'll find that it gives me a statement wherein column sizes have been frozen over from so from the foundation to the second floor and then beyond in itself. So that's what we want in a taller structure. We want to fix the levels at wherein we want to change the sizes. That can actually be very easily be built into the new Planwin. Once I say OK, obviously I can see the geometry here. Another interesting thing I can do now here is go to a given column. I say resize this column, and here say I want them to be square in shape. So I just say design the column, so it gives me square option, and I say I want it to be the same size all across. So I'm just fixing the sizes. I say OK, it changes to a square column, and I just then let's say copy and apply them to all the relevant locations to define my square columns. Of course, as we are now pasting here, it at the back end checks for the sufficiency of the size that we are pasting. So in case it is insufficient, it will actually come and tell us that the column fails at some level and so on. So it's not just an application of the sizes, but actually ensuring that that column size actually works. Now of course we can do, I think what we all believe Planwin helps us do most efficiently is locate and align members. So I can just say push all these members inside, locate them along the edges. So I just select here, I go to this column and say align it at this face here, and this face here. I want to rotate some columns. I go and select the column in question and say okay, rotate it along this edge. It works out the beta and rotates it the way we want to. Select this, I say rotate, and that's it. Now select a tricky column like this and say okay, I'll rotate it like this and align it to the outer face. Similarly I do it for the column here, and perhaps just align these columns. And once I'm through, I just get out of this window and see all my changes have got translated into my actual model in itself. So this is the major value that brings in different shapes of columns, ability to model walls, the whole new experience. I can further take it further, and let's say I want to define member releases. Go into this window, I say release beams. I say I want to release secondary beams. Let's say simply support action for all secondary beams. I just say OK, and that effect gets applied in itself. I can also go into assign and say define support specifications. So they're already fixed, as you can see. You can actually go and change the specifications in itself. I can go to wind, assign the wind parameters very simply, similar to what we had done. And if I go to the seismic parameters, it's very simple definition of the various seismic parameters in itself. You can actually compute the time period, do the time period analysis and so on. And once I'm complete and with my entire 3D model, I can go into analysis and generate the start file. So it says please save the file, so we'll just go in and save this file. So I'll go to a location and save it here. It's called a file called sample. So here you'll see it creates a .plnx file. That's it. All information is stored in one file. There is no other file. So there are no PLW and BLW files. Entire information of the plans, of the frame, everything is one file. So much more easily portable. You can transfer it from location A to B and so on, and not worry about transferring multiple files. So it becomes very convenient in itself. And now I go to analysis. I say generate the analysis file. I define a start file. I can define whether I want to do a seismic or response spectrum or both. So a lot of new specifications that can be defined here. As I generate the file, it creates a start file, as you can see, and also tells us it's been actually been created by using Planwin. So just go into start and just check the file out. So if I just go to sample start file, and meanwhile as the start file opens, if we come in here and actually go into the 3D, you'll actually see the walls that we modeled have got modeled here. So as I described, that we are actually creating the central column and regionally component. So that's actually borne out here in this graphic, and we'll actually see that going into start in itself. So if I go into the start model and I go into the plan, I'll actually go and view this rigid link. So you'll see two things. The size of the rigid link is 3 meters by 0.23. So it's floor deep, and there's the width of the wall in itself. If I go into properties, you'll find that the density of the rigid link is 0. So to ensure the self weight doesn't get doubled and so on. So that's the classical method of modeling walls, which is central column rigid link method in itself. Now I go to analyze. I say run the analysis. I run the start file. So just perhaps takes a moment or two. Now as we are well conversant, all the specifications that we mentioned in Planwin have actually come into the start file in itself. Another value add that Planwin 2014 comes with is an option to directly connect to RCDC. So I can actually go here, go to RCDC and say okay, design slabs, and I select a level. So what it is going to do is pick up the information from your Planwin file, pick up the relevant information from the analysis file, put them both together and actually translate that into RCDC. So you can just go in and start doing your design process in itself. So there is no duplication effort. Oh, it's just saying please close the flat file, so I'll just do that. That's required. So I just go to Planwin and just say create a slab file. So we'll just once again open RCDC and translate the entire information into RCDC in itself. So it's reading the file. So all specifications. So when I'm looking at slabs, you're going to get the slab thicknesses, the loading that we provided in Planwin, the definition of cutout that we defined in Planwin. So all that information is going to get directly translated into the RCDC file. So a combination of both. So what we're trying to do is deliver complete end-to-end integration from a center line in AutoCAD right up to your design and detailing in itself. There you are. So it's just updating information now from Planwin. Just takes a moment, and there, as you can see, all the loads have come in from my Planwin file. The thickness of the members have come in from my Planwin file, and if I can actually zero in on the layout here, I can actually see the cutout has come in from the layout in itself. So complete information translated from the Planwin file onto my analysis file in it, onto my design file in itself. If I go to the model, as I said, it's much more concise. I have just one stat.plnx file, that's it. It creates just one stat file, so there are no 3 files now. There's just one stat file with all information. That entire information goes further into RCDC in itself. So including, as you can see, the definition of the shear walls, etc. have got directly translated into RCDC. So this in a nutshell is the new Planwin, ready to go. Should be with you very soon, and I'm sure you're going to enjoy working with it. Thank you very much.